All right, here we are, P14. So our goal with P14 is to find all zeros of polynomial functions from standard form. And so remember, standard form is the one that does not have all the parentheses. So it's going to be the ones where you can count the number of terms, you look at the largest exponent, and it's easy to find the zero, or the degree, excuse me. So finding the zeros from standard form is going to require us to do some work that you probably haven't quite seen before. And with the way we do this, there's going to be a new process that I'm going to teach you. So I want you to pay attention to the details of this process and the steps that we're going to go through. And this can become really, 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 really easy as long as you pay close attention to the details and the steps of what we're going to be doing. So I need you to understand that we're going to use what's called synthetic division to find zeros. Okay, so we're going to use synthetic division to find zeros. And I'm going to go through the process of using synthetic division. But before I really hop into it, I want you to know that what we're going to do is we're going to take a big polynomial and we're going to divide out a first degree binomial. So I'm going to say it like this just so you can kind of get the idea of what was going to happen, and then I'm going to show you an example or two to get us going. So synthetic division is how we divide large polynomials, so a degree of 3, 4, 5, or 6 or more polynomials, by first degree. Now it's important that we say it like this: first degree binomials. All right, so it has to be a first degree binomial that we divide out. So it would look, essentially it would look like something like x to the third plus, I don't know, 5x squared minus, I'll make it 48x. Let's go with, I don't know, 108. So if I have this big, okay, so this is a third degree, so this is a large polynomial. And if I divide it by, let's go with like x plus 2. Right, so I have a large polynomial. I'm going to divide it by this guy. And so here, this would be the, so let me just really spell it out. This is the large polynomial that I'm going to divide with the, now mind you, it's a first degree, right? First degree binomial, okay? So here's what we're going to do. I'm going to write down the steps, and then we're going to do this example, and I'm going to show you from here what it would really look like. So here we have the steps. Number one, I'm going to take the denominator, right? So I'm going to set the binomial equal to 0 and solve. This will give us the first, I'm going to call this our first 0. So this is going to give us our first 0. The second step is we're going to, now this is made up Stevens language. This is Mr. Stevens language. Not everybody uses this language. This is what I call it, okay? So we're going to create what I call the coefficient board. Almost like a board game. Step 3. Now these are the nuts and bolts. So remember, as we do this, you add down and multiply diagonal. And then step 4, once we have our, we're going to call it with remainder or whatever, we're going to check remainder. Step 5, we're going to rewrite the new polynomial that we get. All right, so these are the steps that we have. And here in a second, I'm going to go through and do the example. I'm actually going to do this one here, just so we can see it. Okay? So, those are our steps. And let's just take a look one more time. If I have, let's say, you know what, I'm going to write it like this. I'm going to do it like this. Here's the polynomial function. So we're going to start with the polynomial function f of x equals x cubed plus 5x squared minus 48x minus 108. Okay, here's the first. This is a polynomial function in standard form. So we're going to rewrite this, and you know what? Let's do this. My goal. So over here, I'm going to write this out. My goal. Let's write this like this. We're going to write in factored form. So my goal then is to get all the factors. And let's say that our first factor that we get. So let's say we're given this function, and let's say our first factor is x plus 2. So they tell us, here's the polynomial function, and we have a factor of x plus 2. All right, so essentially, I want to take this and divide it by x plus 2. Right? So let's start. This is going to be my denominator. This is my binomial. I'm going to set it equal to 0. So x plus 2 equals 0. And I go x minus 2 minus 2. So x equals negative 2. All right? So this is important. Now I have my step 1. Right? So here we go. Step 1. Step 1 is set the binomial equal to 0. Solve. All right? So this is my first, technically, this is my first 0. So the first 0 we have is negative 2. All right, now the second step, I want to create the coefficient board. And here's what this looks like. It's an L that just didn't quit. Right? And then out here on the front porch, that's where I'm going to put my first 0. So then my negative 2 goes there. So when I set the binomial equal to 0, whatever number I get, that's going to go out on my front porch. Now it's called a coefficient board because I need the coefficients of the original polynomial. So the coefficient of x to the third is 1. The coefficient for 5x squared is positive 5. Negative 48x is negative 48. Negative 108 is negative 108. All right, so I've created my coefficient board. Now step 3 says add down and multiply diagonal. So I'm going to start here, and there's nothing to add with it. This guy always goes straight down to this one. And now negative 2. So I multiply, so I add down and multiply diagonal. Negative 2 times 1 is negative 2. Add down. 5 plus negative 2 is 3. Multiply diagonally. Negative 2 times 3 is negative 6. Add down. Negative 48 plus negative 6 gives me a negative 54. And now multiply diagonally. Negative 2 times a negative 54 is a positive 108. And this, add down, will be my remainder. So this is my remainder spot. Now in the remainder spot, if it is not 0, so if it's any number other than 0, then this would not be a factor of the original function. All right, so the binomial x plus 2, since I got a remainder of 0, then the binomial x plus 2 is a factor of x to the third plus 5x squared minus 48x minus 108. All right, so that step 4, check the remainder. Right? I've checked my remainder. It is 0. So then that tells me that x plus 2 is a factor of the original. And now I have to rewrite the polynomial. So I'm going to convert it from coefficient form back into polynomial form. Well, much like we went from polynomial form into coefficient form, this 1 was x to the third, 5 was x squared, negative 48 was negative 48x, and negative 108 was negative 108. Now look at the exponents. X to the third, x to the second, x to the first, and no x's. Right? 3, 2, 1, none. And if I divide 1 out, so 3 x to the third divided by a single x would be x to the second. So it went from 3, 2, 1, none. Now 3 minus 1 would be 2. So this now represents an x squared. X, no x. So this 1 becomes x squared plus 3x minus 54, right? 2, 1, and none. My exponents, my x to the second, x to the first, no x at all. So I'm getting a little bit closer. I'm not quite in factored form yet, but I am closer, right? Now I have x squared plus 3x minus 54 times x plus 2. Now I want to factor this trinomial, and we've done a lot of these at this point. So here, I'm going to factor this. I get an x and an x. And the factors of 54, that subtract to 3 are going to be 9 and 6. So I get plus 9 and minus 6. So when you get really good at factoring, from here to here, this is going to be really, really simple. And now, I'm in factored form. Ta-da! Factored form. Exclamation point. And maybe go a little woo. All right. Now the last thing, I need to find my zeros. Well, I'm going to set each one of these equal to 0, and I already know this one, right? So when I'm going to state my zeros, I know this one is going to be negative 2, right? We did the work on it. So I say x plus 9 equals 0, minus 9, and x equals negative 9. So negative 2, negative 9, and now my other one, x minus 6 equals 0, plus 6, x equals 6. And these are all of the zeros of the original function. So we were able to start in standard form, end up in factored form, and state all of our zeros. So again, we're going to go standard form to factored form. Once we're in factored form, then we can state our zeros. Okay? Let's try... actually, we don't have enough time left on this video, but hopefully you could use this example to go through and get the majority of the homework done. And if you have questions, as always, make sure you're asking questions.